Hello, everyone, and welcome to our presentation on the world server. We are thrilled to share this journey with you guys today. So, our project basically centers around us creating a virtual world that is managed by a sophisticated server and populated by interactive robots. In this presentation, we will be showcasing all the tools and technologies that were used, which includes Java for server development, SQL or SQL for database management, Docker for environment, consistent environments, and various testing and documentation strategies. We will also present a cost benefit analysis to highlight the value these tools have brought to our project. Let's dive into each aspect and discuss how these elements contribute to the overall success of our project.
Let's dive into the tools and technologies that were central to our project. These choices were made based on our project needs, team expertise, and the specific challenges we anticipated. Java was our primary programming language. Java renowned for its scalability and robustness, which were critical for our server-side development. The language's object-oriented principles allowed us to create modular, reusable components, which helped streamline the development process. Java's strong typing and exception handling features were particularly beneficial in building a reliable server that could handle various commands and maintain the persistent state of our virtual robot world. For data management, we turn to SQL, a powerful language for relational databases. SQL enabled us to efficiently manage the persistent state of our robot world map, including storing the position of robot and various environmental features like obstacles. By using SQL, we ensured that our data handling was both structured and reliable, with the ability to perform complex queries and maintain data integrity across different scenarios. Java database connectivity. To bridge the gap between our Java application and the SQL database, we utilized JDBC. This API allowed us to connect to the database, execute SQL queries, and manage the database's state directly from our Java code. JDBC provided the flexibility needed to perform dynamic database operations such as saving new worlds or retrieving obstacle data based on user commands, all while maintaining a consistent interaction layer between the server and the database. Docker consistency across different environments was a key concern of our project. Docker came into play by allowing us to containerize our application, ensuring that it ran the same way on all our team members' machines, as well as in our testing production environments. By containerizing our application, we could isolate it from the host environment, reducing the "it works on my machine" issues. Docker also simplified the deployment process, allowing us to package all dependencies and configurations into a single portable container. CI/CD tools. With Docker image integrated into our continuous deployment pipeline, we automated testing and deployment processes. Every time we make changes to the code base, the pipeline would automatically build the Docker images, run tests, and deploy the application if everything passed. This automation drastically reduced manual errors and sped up our development cycles, allowing us to focus more on writing code and less on managing deployments. The integration also provided immediate feedback on the impact of code changes, which helped us maintain a high level of code quality throughout the project. We use CodeScene for analyzing our code base, which turned out to be a valuable tool in identifying potential issues early on. CodeScene provided us with insights into code complexity, hotspots, and technical debt, allowing us to prioritize refactoring and improvements. By highlighting areas of the code that were both complex and frequently modified, CodeScene helped us focus our efforts on parts of the code base that were most likely to cause future issues, improving overall maintainability and reducing the risk of bugs. GitLab was our go-to platform for project management and version control. It played a crucial role in managing our task, tracking progress, and facilitating collaboration among team members. Through GitLab, we were able to create issues, assign tasks, and manage merge requests efficiently. The integrated features of GitLab also meant that we could manage our projects from the same platform, streamlining our workflow. Version control was essential for ensuring that all team members were on the same page with GitLab capabilities, allowing us to work on different features simultaneously without conflicts. Each of these tools was chosen deliberately to address specific challenges and needs of our projects. Together, they formed a cohesive tech stack that supported our development from start to finish, whether it was writing code, managing data, ensuring consistent environments, or automating our deployment pipeline. These tools enabled us to deliver a robust and reliable product. As we introduced these new stories into the code base, maintaining code quality became a top priority. CodeSyn, which we had already been using for code analysis, played a crucial role in this phase. The tool provided us with insight into how the new stories were affecting our code base, particularly in terms of complexity and potential hotspots. We paid close attention to areas of the code that were most impacted by the new features. This ongoing analysis helped us identify parts of the code that might need refactoring or additional testing to ensure they remained maintainable and free from bugs. CodeSyn's ability to track the health of the code base over time was particularly valuable as we implemented new features. We could see the immediate impact on code quality and make informed decisions about where to focus our efforts. This proactive approach allowed us to stay ahead of potential issues and keep our code base in good shape as the project grew in complexity. Maintaining high code quality with the combination of rigorous backlog management and continuous code analysis helped us maintain a high standard of code quality throughout the iteration. By addressing missing scenarios and monitoring the health of our code, we could confidently move forward with the development, knowing that our foundation was solid. This iterative process of identifying gaps, adding new stories, and continuously analyzing our code became a key part of our development strategy. It not only ensured that we deliver the required features, but also that those features were built on a stable and maintainable code base.
Docker has been very instrumental in creating a consistent runtime environment for our application. So by packaging our application and all our dependencies into a Docker container, we eliminate the environment consistencies and we simplify the setup process for this project. Docker also plays a key role in our pipeline. We use Docker images to build, test, deploy our application, ensuring that every stage of development and deployment is reliable and repeatable.
Incorporating Docker into our CI/CD pipeline allows us to automate the build, test, and deployment processes. Each Docker image starts from a clean state, ensuring consistency across the different stages of our development. We perform testing within these Docker containers, which helps us catch issues early. And once our tests are successful, the Docker image is, well, rather a newer version of that of a Docker image is published and used for deployment. This reduces the risk of discrepancies between our development and our production environments. Now, let's explore our SQL implementation in the web application. Here in this section, we will showcase how our SQL queries are optimized and how we ensure data integrity throughout the whole system. Here's how we handle concurrent data access and maintain consistency through SQL functionalities. So we have a Vault database manager, which basically is responsible for connecting to our database and also closing off that connection. So regardless of which domain aspect is requires database access, we use the Vault's database manager. And then now moving on to how we maintain consistency and data integrity, we basically implemented a object relational mapper. Now we have three articles that we really store in our database, three tables, so as to say. So we have a world, and each world has a name. Each world has a name and a length and a width. And we also have obstacles that have a that have that have a type, that have a start position and an end position. So first things first, we we are going to show you our world data access interface. Now this is where we are running our SQL queries using ease of development SQL. So now the main purpose of this data access interface is to is to standardize how we create our domain objects based on what is stored in our database. So when we want to get when we want to get a world by its name, we can map it back to a world uh, database object. Now, a world data object. I mean, so we have we have a function get world by name, which basically runs this SQL query, and then it's it selects a world from our database based on that name, and then it maps it back to to uh, this world data object, which later on in the domain code this can be used to create a new world uh, in our actual domain code. And then we we have a get all worlds in our database, and now this basically fetches all of the world entries in our database and return them as a list of world data objects, which can be mapped again uh, back to create new world instances in our domain code. And we have an insertion. This is how we basically save a world into our database by its name, length, and width. And then we can also modify things in 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 our worlds table in our database, and that is by using the update world function in our world data access interface. And then we have a a deletion of worlds, which basically deletes a certain world, and then because of how we also created our database, it will cascade every other reference is- that uses that particular world, so as to say. And then moving on, since our database has a intermediary table code world obstacles. So now this basically ties every every obstacle that we have in our database to a specific world. So this was merely done to like really.
Next, we'll discuss how we executed our test plan. We used specific input data to validate the functionality and performance of our system. We'll also cover any deviations from the test plan and how we ensured that the test standards were met. Finally, we'll demonstrate how we verified database access functions and ensured that they performed according to their requirements.
As you can see here, we have 3 reference servers. Each iteration, we would test our acceptance tests against our reference server to ensure that all the tests passed. Once the tests passed, then we would test them against our own servers. And if they failed, we would have to make corrections to our own server to ensure that they passed. This really ensured that we were testing the right things, and we were testing in a way that ensured our program actually ran efficiently and effectively to ensure best practices. Here's an example of how we tested out our acceptance tests against our reference server. So firstly, I will run our server, and now I'll run our acceptance tests against our server. As you can see, they all pass, just as they did against our reference server. This ensured that our server ran effectively.
I'll be presenting the documentation aspect of our project, focusing on how we've structured and evaluated it for consistency, design adherence, and alignment with our program's goals. From the outset, our approach to documentation was meticulously planned to adhere to specific standards. We developed a comprehensive design blueprint that guided us in creating each component of the documentation. This blueprint ensured that every piece of documentation was not only consistent with the overall design but also aligned with the program's objectives. Our documentation is available through the project wiki, which is divided into several key sections. Welcome to Robot World, or the homepage. This introduces users to the project, providing an overview of the virtual realm we've created where robots interact with various elements like mountains, lakes, and pits. Setup instructions. This is a detailed guide on how to set up the environment, compile the code, and run both the server and the client, ensuring users can get started quickly. How to play. This section explains the game's mechanics, including how to launch robots, issue commands, and navigate the world. It also covers combat and winning strategies. Pipeline. Here we outline the stages of our CI/CD pipeline from building the code to deploying the application. This ensures transparencies and clarity on how the code is continuously integrated and delivered. Docker is a guide on building and running the application using Docker, catering to users who prefer containerization. Game rules. This details rules that govern the gameplay, ensuring that users understand the boundaries and objectives within Robot World. In addition to the wiki, we also provide a comprehensive README file, which serves as the first point of contact for anyone interacting with the project. The README file includes a project overview, which is a brief introduction to Robot World, highlighting its purpose and main features, installation instructions, which is a step-by-step guide on how to set up the development environment, including prerequisites and commands to compile and run the project. Usage instructions. This is basic commands and example to help users get started with the application quickly. Contribution guidelines, directions for contributing to the project, encouraging collaboration and ensuring that contributions align with the project standards. The README file is designed to be user-friendly, providing essential information at a glance and linking to more detailed sections within the wiki as needed. We ensure that the documentation was not only consistent in tone, style, and structure, but also accurately reflected the functionality and features of the program. Each section was crafted to align with the actual code base and user experience, providing a coherent and practical guide for users. In evaluating our documentation, we ensured it was created according to the design standards agreed upon during the planning phase. We structured the documentation sensibly, making it easy for users to navigate and understand. Additionally, we made sure that each part of the documentation directly addressed how the program's specifications were met. Our documentation is not just a byproduct of the development process, but a carefully crafted guide designed to enhance user experience and maintain consistency with the program's goals. We've adhered to our pre-created design, ensuring that the documentation is both informative and user-friendly.
Now we'll present our cost and benefit analysis for the development of our project. We'll break down the cost associated with each major component and compare them against the benefits we achieved. Cost estimate, for example, the development of a web API using the Javelin framework was estimated to cost around $570 to $950 per hour for a junior developer, including both development and testing phases. This estimates also includes cost associated with integrating the API with existing components, such as database and Docker containers. We also considered the cost of potential additional resources required for handling any unforeseen challenges. Effects of late delivery. Late delivery of the web API could have impacted the overall project timeline, affecting integration with mobile app and delaying subsequent development phases. This could lead to increased cost and reduced project efficiency. We analyzed how such delays could potentially impact other related components and overall project deliverables. In summary, our cost and benefit analysis demonstrated that the investments in tools and development phases were justified by the benefits of improved project efficiency, consistency, and functionality.
In conclusion, our project effectively integrates Java, SQL, JDBC, Docker, and CI/CD tools to create a robust and reliable virtual world. Each tool and technology has been crucial in ensuring the success of our project. We really appreciate your attention, and we are open to any questions that you might have about our project. We look forward to discussing any aspects in more detail or clarifying any points you may have.